Hey there, everybody. You're watching our first of two lessons on percents. We're going to spend two lessons on this topic so that if you end up being a parts manager, for example, you can deal with different percentages that go along with the finances of a shop, and also as a technician, so you can work through some of the basic percent situations that you'll have to come up against. So let's go. Let's start with the word percent. If you take the word percent and break it down, the word percent literally means per hundred. Per means divided by, like we saw with unit rates and ratios, and cent is the metric prefix for 100. So percent literally means per hundred. So when you hear the statistic that a turbocharger increases a certain engine's torque by 12%, then you can say that as a ratio or as a fraction. So that means that 12% literally means 12 out of every 100, or if you reduce that down and treat it like a fraction, it means that you gain 3 foot-pounds of torque for every 25 the engine was already making. That's a 3 out of 25 increase. And just kind of as an interesting side note, as long as we're talking about torque, um, found an interesting picture of a turbocharger there. That's a turbocharger off of a shipping barge. It's huge. And as a point of reference, the turbocharger on the 12-cylinder engine in a big ocean shipping barge like that one, the engine produces 72,000 horsepower at just 97 RPM. So from our work with torque and horsepower, if that engine's making 72,000 horsepower, but it's only turning 97 RPM, remember horsepower is the product of torque and RPM divided by 5252. So if we don't have many RPM, there must be a phenomenal amount of torque coming out of that engine. It's a staggering amount of power. So with that in mind, that means that we can take percentages and write them as fractions and then move them into lowest terms. So let's do that right now. Let's take a look at these three examples. So let's take the decimal 17.4% and express that as a fraction in lowest terms. Well, we know that 17.4% can be written as 17.4 per hundred. That's what a percent is. That gets us a ratio or a fraction, but we don't like decimals in that. We saw that in our lesson on ratios just a little bit ago. So we can chase the decimal 1 to the right to make the top 174. And if we do the same thing on the bottom, that becomes 1,000. So we have 174 over 1,000. But those both divide by 2 and reduce to become 87 over 500. That is our equivalent fraction in lowest terms. Our second one there, 225%. Well, again, 225% means 225 per hundred. But those both divide by 25 to become reduced. Divide the top by 25 and you'll get 9, and the bottom by 25 to get 4. That leaves us with an improper fraction, which we could call 2 1/4. And that's 225% written as a fraction. Our last one here, the legal limit for blood alcohol content is 0.08%. That's the legal limit to operate a motor vehicle in Wisconsin. 0.08% is a fraction. That's the same as 0.08 per hundred. Percent means per hundred. Now we can chase that decimal out by moving it 2 to the right. That becomes 8. 2 places to the right on the bottom becomes 10,000. Now those both divide by 8 to become reduced. Divide the top by 8 becomes 1. Divide the bottom by 8 becomes 1,250. So that means one drop out of every 1,250 drops of blood in your system is 0.08%, and that would put you at the legal limit. Now that leads to something that you might remember from math you've had before. When you convert a percentage to a decimal, you move the decimal place 2 places to the left. Why is that? Well, let's go back and look at these examples we just did. If you take 17.4% and think about what the decimal equivalent of that is, we can find it by just taking our fraction and dividing it on a calculator. When you divide 87 by 500, which is the fraction we figured just a minute ago, you get 0.174. So that's our fractional form of the percent turned into a decimal. Now look at what we've got. We have 17.4%, and we just showed that that is equivalent to 0.174. We could have got that by just taking our original percentage and moving the decimal 2 spots to the left. We can do that in our second one too, 2 1/4. You don't need a calculator to know that that is 2.25, but 2.25 is exactly what we had if we would have taken 225% and moved the decimal, which is on the right edge of the number, 2 places to the left. That would have given us the decimal equivalent. And so 0.08% could have been done the same way. If we take 1 and divide it by 1250, you get 0.0008, which again is 2 places to the left from our original percentage. So you take a minute and make sure that you can do both of those things. Take these 3 percentage values and write them both as reduced fractions and as decimals. Pause the video and resume when you're ready to see what those equivalencies are. Okay, let's start with 65.5%. Let's do the fraction first. That's the same as 65.5 per 100, which we can move the decimal to the right to say is 655 per 1,000. Both of those numbers divide by 5 to reduce to become 131 over 200. There's our lowest terms fraction. And if you divided that on the calculator, you'll get the same thing as if we move our original decimal and our percent 2 places to the left. That becomes 0.655. Those are the two values you should get. Our next one, 325%. That's the same as 325 per 100. Those both divide by 25, and we get 13 over 4. But that's the same as 3 1/4. So there's our equivalent fraction. And no surprise, if we would have taken our original decimal and moved it 2 places to the left, we'd have 3.25, which is of course equal to 3 1/4. And our last one, 0.42%. As a fraction, that's 0.42 per 100. But we can chase out the decimal and make that 42 over 10,000. But those both divide by 2 to become 21 over 5,000. There's our lowest term fraction. And if we divide that on your calculator or move the decimal 2 places to the left, in either case we'll get 0.0042, and we're done. That's what you should get. If any of those gave you trouble, make sure to watch that explanation again. That's one of the important skills you'll be using in your practice problems and skill check for today. The other thing we can take away from this is that when we have a decimal like 0.655, we can just move that decimal place 2 places to the right to turn it back into a percent. That becomes 65.5%. One way that I've heard it said is that if you want a decimal to become a percent, you move the decimal 2 places towards the percent sign. So 3.25, if we want that to become a percent, 2 places towards the percent sign becomes 325%. 0.0042, we want that to become a percent. 2 places towards the percent sign becomes 0.42%. So then we can generalize that and say that if we have a decimal like 0.417 and we want that to become a percent, we'll move the decimal towards the percent sign and that becomes 41.7%. And if we have a fraction like 3/4, first we'll just divide to turn that into a decimal. That one we know is 0.75. Then move the decimal 2 places to the percent sign and this becomes 75%. So that's in general the reason that we take a decimal to a percent by moving the decimal point 2 places to the right. So look at this situation. Hydrocarbon gases can cause irritation to your eyes. That's basically unburned fuel, which is why you need to have good ventilation when you're running an internal combustion engine. Otherwise you can feel it. Your body doesn't respond well to hydrocarbons. So if we take 2,000 parts per million and want to figure out what percent that is, 2,000 ppm or parts per million is literally the fraction 2,000 out of every million molecules. Now, there's our fraction. We can cancel off some of those zeros and say that this is equivalent to 2 out of every 1,000, which we could reduce even more and call 1 out of every 500. Now, the decimal equivalent of that, 2 out of 1,000, that's 2 thousandths, that's 0.002. The question we were asked is, what percent is that? Well, 0.002, if we turn that into a percent, is 0.2%. And so 2,000 parts per million in the end is the same as 0.2%. I want to note that we didn't have to get the fraction there. I was just showing that we could reduce that down to 1 out of 500. What really matters is that 2,000 parts per million is 2 out of 1,000, or 2 thousandths, which is 0.2%. Okay, I want you to take just a minute, pause the video, and convert each of these 4 values into percents. The 3 values you see on your screen, as well as the bottom question. Unpause the video when you're ready to see those solutions. Okay, here we go. 0.964. Well, if we want to turn that into a percent, we'll just move the decimal 2 places towards the percent sign, and that is, of course, 96.4%. And that's all there is to that. 19 out of 20, well, we need to turn that into a decimal first. If you divide that on your calculator, you'll find that that's 0.95. Decimal 2 places to the right, and that is equivalent to 95%. 3 out of 400, that's 0.0075. And if we move that decimal 2 places to the right, that's 0.75%. And the last question, hydrocarbon gases can cause you to pass out if they hit 20,000 parts per million. What percentage is that? Well, 20,000 parts per million is the same as 20,000 over 1 million. And we can reduce that as well. And in fact, this time we can cancel out 4 zeros out of the top and bottom. And that becomes 2 out of 100. And of course, we know that that is 0.02, but in either case, we know that 2 out of 100 is 2%. Hopefully those are the values you got, but if not, you might want to rewind that and make sure that you learn from any mistakes you made. Now, the second thing that we want to do in this topic is actually start solving some percent problems. And one way to do that is by recognizing that every percent problem you'll ever come across has 3 main parts to it. They are the base, the rate, and the amount. So let's explore that a little bit. Let's take an example. Suppose you have 1 in 4 trucks in a fleet that are overdue for their oil change. That's a simple enough ratio. We would say, and I think you'd agree, that 1 of those trucks is 25% of the 4 in the fleet. So 1 out of the 4 is overdue, 25% are overdue. Well, there's your 3 numbers. 1, 4, and 25% are the 3 numbers that form this relationship. Each one of those has a name. First of all, the base. The base is the full amount of whatever thing that you're talking about or measuring. In this case, that's all 4 trucks in the fleet. The base is always the whole thing, or 100%. And the base almost always shows up next to the word of. We said that 1 is 25% of 4, and right there, of is showing next to the number 4. The second component of every percent problem is the rate. Rate is the percentage that we're talking about. In this case, we said that 25% of the trucks are overdue. That means that our rate is 25%. The rate is easy to spot because it's always got the percent sign by it. That's always your percentage in the problem. And finally, the amount is whatever the percentage represents. So that 25% represents 1 truck. That is the amount of trucks that are overdue for their oil change. And that almost always shows up next to the word is. So let's take a look at a couple of percent statements and identify the base, the rate, and the amount. Let's look at these 3. The first one, 3% of 150 is 4.5. There's no question there, that's just a fact. So what are your base, rate, and amount? Well, first of all, 3% is the rate because it's got the percent sign by it. The rate usually jumps out at you. Now, what's the whole thing? The whole thing is 150. That makes it your base. And 4.5 is the 3%. That's the amount that that's worth. In our next one, 11 is 25% of 44. Well, 25% is your rate. The base is 44 because that's the whole thing. And the amount is 11. Our last one, a test score is 35 out of 40. That's 87.5%. 87.5% is your rate because that's your percentage. What's the base? Well, the base would have to be 40 since that's how many questions there were. And the amount we got right is 35, so 35 is your amount. Every percent problem has those three numbers in it. And the key is that the base rate and the amount are always related by the same relationship, kind of like our force, torque, and lever arm circle. As long as we know two of those three, we can find the third one. The key is that our rate always has to be entered in decimal form when we use this circle. So let's answer a couple of questions here. The first one, what percentage of 150 is 6? Well, I think that you would agree that the numbers we're given are 150 and 6. The question is what percent, so that means we are trying to find the rate. And so our rate, according to our wheel, is found by taking the amount over the base. So then what roles do the 150 and the 6 play? Well, 150 is both next to the word of, and that's the whole thing. So 150 is our base, and 6 is our amount. So that means our rate in the answer to this question is the amount, 6, divided by the base, 150. And if you divide that, you get 0.04. Now remember, when you use this wheel, the rate is always a decimal. If we want to turn that into a percent, we'll go 2 places to the right, and the answer to our question is 4%. So we could say that 6 is 4% of 150, and we've answered the question. The second one, 80 is 64% of what number? And so we're given the 80 and 64%. Well, 64% is definitely our rate. So the question is, are we looking for the base or the amount? Ask yourself, is 80 the whole thing here? No, 80 is only some part of the whole thing. It's only 64%. So 80 is not the whole thing. It must be the amount, which means we're trying to find the base. Our wheel says that to find the base, we should take the amount and divide it by the rate in decimal form. Let's do that. Our base then is the amount, 80, divided by the rate, 0.64. 80 divided by 0.64 is 125, and that answers our question. We can then say that 80 is 64% of 125. So in other words, if you took a test with 125 points and you got 80 right, you would have earned 64%. Okay, I would like you to take a minute and answer these three questions. Pause the video, work these through, and unpause when you're ready to see those solutions. Okay, our first one, 4.2 is what percent of 40? We're given the 4.2 and the 40. 4.2 isn't the whole thing, that's our amount. 40 must be our base, which means we're looking for the rate. If you use your wheel, rate is amount divided by base. And so in our case, our rate is going to be 4.2 divided by 40, and that is 10.5%. We're done. 30 is 45% of what number? Well, we're given the 30 and the 45%, and clearly 45% is our rate. Is 30 the whole thing? No, it's less than half of the whole thing, so that must be our amount. And so our base is amount divided by rate. And so in our case, that means the base is going to be 30 divided by the rate, which is 0.45 in decimal form. and that turns out to be about 66.7. And that answers our second one. This brings us back to the type of question we were working on earlier. If you're at the legal limit for operating a motor vehicle, that means 0.08% of your blood is alcohol. So if the typical human has about 6 quarts of blood in their system, then how much of that is actually alcohol flowing through your bloodstream? Well, we know that 0.08% is our rate. And the whole blood system for a human is 6 quarts. That must be our base since it's the whole thing. And to find the amount, we want to take the base times the rate in decimal form. So in our case, that's going to be a base of 6 quarts times the rate, which is 0.08%, but we need to put that in decimal form. So to convert it to a decimal, we're going to go 2 places to the left, and we get 0.0008. And that means the amount of alcohol in somebody's bloodstream is 0.0048. Now, those units are still in quarts. If we wanted to turn that into ounces, we can do a unit conversion and put that over 1. 1 quart contains 32 ounces. So if we multiply that out, we get 0.15 ounces or so, which is a very, very small amount of alcohol. There's one last example I want to work through with you here, checking a tolerance. So an electrically heated seat relies on resistance coils to heat up that seat, and sometimes they fail. One way to check them is to check the resistance of the entire heating circuit. So a spec is that it should be 350,000 ohms plus or minus 5%. Then what's the acceptable range of values? Well, 350,000 is what it should be. That would be the full resistance. That means that's our base. The 5% that we're allowed in either side of that, our tolerance, that must be our rate. And we want to find the amount that we can actually vary. So amount is found by taking base times the rate. So for us, that means that we're going to take 350,000 times our rate, which is 5%. We need to turn that into a decimal by going 2 places to the left. That's 0.05. And that means that we can be 17,500 ohms above or below our spec. So that means that our minimum value is going to be 332,500 ohms. That is to say, that's 17,500 below 350,000. And our maximum will be 350 plus 17,500. That's 367,500 ohms. That's the acceptable range of values. All right, here's the last question of this unit. Oil pressure in a certain turbocharger should be 35 psi, give or take 12%. I want you to calculate what the maximum and minimum values are in terms of that pressure. Okay, well, this is real similar to the last example we did. Our base is the full oil pressure. That's going to be 35 psi. Our rate is the 12% that we can vary from that. And so we want to find the amount that we can vary. So that's going to be base times rate. So the amount we can vary is going to be 35 psi times the decimal form of 12%, that's 0.12. And that turns out to be 4.2 psi. So the acceptable range of values is 35 psi plus or minus 4.2. So our minimum value would be 35 minus 4.2 or 30.8 psi. And our maximum would be 35 plus 4.2 or about 39.2 psi. There's our acceptable range. The lower one is our minimum, and the larger one is our maximum. Okay, well that wraps up this unit. The main things that you should have gotten out of this lesson were 1, percent literally means per hundred, and that means you can treat any percent value as a fraction or as a decimal. And the main reason we want to work with fractions as decimals is that so that we can solve percent situations or percent applications where we have a base, a rate, and an amount, because then we can always use the relationship between amount, base, and rate to solve when we're missing one of those three parts. So in our next lesson, we're going to work a bit more with solving percent applications. So do the practice problems for this section, and we'll wrap up our work with percents in the next lesson. We'll see you then.